Good morning. Just for a few minutes, just have the Wi-Fi setup. But today, the topic of discussion is in machine learning about the clustering concepts. So clustering is basically a grouping of a process of grouping a set of identical objects. It is a process that is followed for identifying the particular set of groups. Say, let's say, like an medical domain. Suppose the patient's symptoms are collected, and based on the symptoms that is being collected, we can able to categorize the uh, the disease, the group of people who are all affected with the particular disease. So it's mainly comes under unsupervised learning. In contrast to classification, we use supervised learning, where in supervised learning, the data set is being provided with all set of values, attributes. Whereas in clustering, we don't have labeled data. Now, the algorithm, machine learning algorithm, will try to identify the shapes based on shapes, or based on color, or based on texture. Now, you can able to learn and grasp the information, and the model gets trained based on so many data that is being given put to the model to understand what is this kind of object. So learning happens uh, regularly, and it also gets feedback based on its learning. It understands and it gets update the knowledge of the information or the data. So it uses the similarity principle, and a cluster is basically a collection of data objects, all the similar features which are there that can be grouped in the same group. The unrelated objects or dissimilar objects will be placed in other groups. So it follows an unsupervised learning where it learns by observations. So, so if you look at this diagram, now these are all the initial data points. These data points are being used in this space, two-dimensional space. Each point have x comma y values. So these can be categorized based on shape or based on some colors. We can able to classify them. So for that, we need to have some kind of algorithm to identify how many number of clusters that we want, and what are the parameters that can be used to identify these the points belongs to this particular clusters. So these are all two clusters have been formed. There are four clusters have been formed. So, so the most popular clustering algorithms that is used is K-means clustering algorithm. Uh, we have, which comes under partitioning algorithm. We have so many other algorithms. Hierarchy clustering is also there. So in K-means algorithm, it is very simple, and it is the most popular algorithm that is used. K denotes how many number of clusters that is required. And in hierarchical clustering, we follow tree-like structures basically. And DB-scan, it denotes a density-based spatial clustering of applications with noise. So these clusters are formed based on density. Some of the real-time examples of clustering is anomaly detection. Anomaly, you can able to identify and detect this is comes under anomaly. So in computer networks, if you see, if there are capturing data, so many services are running in the server. If you're trying to capture the packets, and if you want to streamline which are all anomaly and which are all normal, now you can able to use clustering algorithm to classify the anomalies. And most important applications in e-commerce applications, customer segmentation can be used. So, like basket, going to a mall, going to a supermarket, and the customers, the information, it will be able to categorize the customer, the taste, what is the behavior of customers, and how it could be improved. So there are few customers, they will be regularly coming to supermarkets, and they will be buying these the group of similar items. So you can able to categorize segments. The other application is based on the social media. So where we can able to, based on the interest, we can able to check, right, whether the users, what kind of interest the user have. In most popular applications in medical, where we can able to diagnose, we can also categorize the symptoms and classify it. So we can able to detect, we can apply some clustering algorithms, then we can to identify the uh, similar items. So this is a simple example where we've given a group table of students and the scores masked by students, different students in maths and science. So in K-means clustering algorithm, we use a partitioning method. So given a data set of information of n objects that will be categorized into K clusters such that the sum of squared distances is minimized steps. So here we use the total objects, the total database will be converted into K non-empty subsets. And for everything, we're trying to identify the centroid, feed point, the centroid of the clusters. And partitioning again, it happens. And you're trying to assign each object to cluster within the nearest. So based on the distance between the points, and we are trying to categorize whether this points comes in the type of cluster. So these will steps will be repeated when there is all the data points has been clubbed in the clusters and there are no other data points left out. So thank you all.